So recently I've been working on a few pieces inspired by the space and our universe. And naturally, I was very interested in the ancient idea of how music and the universe are somehow related. Since a long time ago, humans have always been fascinated by the relationship between music, mathematics, and astronomy. One of the first persons to connect these three disciplines is the ancient Greek philosopher Pythagoras. He famously came up with a way to derive musical scales with simple mathematical ratios. And besides that, he's also commonly regarded as the first to associate music with celestial objects. According to him, music intrinsically exists in our universe, and the sun, the moon, and other planets all emit a unique tone based on their orbital patterns. This kind of music, however, is not something you'd hear on your headphones, but it's more of a philosophical concept that everything in the universe is governed by a kind of divine harmonics. As Pythagoras says, there's geometry in the harmony of the strings, there's music in the spacing of the spheres. He even goes as far as to measure the distance between celestial objects using musical intervals. For example, the distance between the Earth and the Moon is supposedly a tone, between the Moon and Mercury a semitone, between Mercury and Venus another semitone, and so on. This entire idea was known as Musica Universalis, or music of the spheres, and it became extremely influential for later generations of scholars, attracting the thoughts of people like Johannes Kepler, a 17th century astronomer and mathematician. Building upon Pythagoras' idea of Musica Universalis, Kepler extends this idea more and even suggests the possibility of four-part counterpoint among the planets, and assigns each planet to soprano, alto, tenor, and bass parts. So all these sound really abstract and far-fetched, and we, with the advantage of being born into a much more scientifically informed era, might be thinking of how wrong these ancient people were, right? I mean, Pythagoras, along with all the other people in his generation, thought that the Earth was the center of the universe. And what about the whole thing of relating different planets to music? Well, there's host, but besides that, it seems really impossible to draw any connection between the two. I mean, heck, there's no air in space, so it would be impossible for us to hear any music in space. So this whole thing must just be total bullshit. Or is it? Well, let us think about what actually creates music. Essentially, it's sound, and sound is the result of vibrations. When we pluck a string, the vibration of the string is transferred into the vibration of air molecules, which when picked up by our ears, is translated to what we know as a sound. These vibrations are caused by constant oscillations of air molecules. And now, what else moves about in constant oscillations? Yup, planets. The rate of planets in the solar system orbiting the sun is more or less constant, and because of that, it is technically possible to create a stable pitch for each planet, depending on the frequency of their orbits. For example, Mercury, which orbits the Sun every 88 days, would have a much higher frequency than, say, Jupiter, which orbits the Sun every 12 years. So how does this translate to sound? Well, sound, specifically those within our hearing range, has a much higher frequency than planets, as we can hear pitches from 20 to 20,000 Hz, which means 20 to 20,000 vibrations per second. Okay, great, so that means we are never gonna hear the sounds of our planets. Well, not unless we greatly increase the frequency of all planets into our hearing range. So I'm gonna try to map out the 8 planets in our solar system and based on their orbital frequencies, come up with the pitch of each planet. By bringing all the frequencies up into our hearing range, here's what I have. Since a higher frequency means higher pitch, the inner planets will have much higher pitches than the outer planets. So, in the spirit of Pythagoras, this could be the way of understanding our planets through music. And without further ado, I present to you the beautiful harmony of our solar system. Well, that was probably not what Pythagoras thought the universe sounded like. At least to me, that sounded pretty bad. For one, the notes fall in the extremes of our hearing range. I mean, I can barely hear the lowest and highest notes produced by Neptune and Mercury. So the range is just way too wide when compared to the music we normally hear. Also, some of the notes sounded really clashy and dissonant. Let's go back to Pythagoras for a bit and try to understand why our solar system sounds this way. So the Pythagorean method of deriving a musical scale all comes down to simple ratios. Each interval, or the distance between two notes, can be represented by a ratio of their frequencies. For example, an octave has a ratio of 2:1. A fifth has a ratio of 3:2. And what Pythagoras found out was that the simpler the ratio, the more consonant or stable the interval. With more complex ratios that are indivisible into smaller numbers, they tend to sound more dissonant, clashing, and even out of tune. So simple ratios are consonant and harmonious. Complex ratios are dissonant and clashing. Now, let's look at our solar system again and see what kind of ratios different planetary orbits have. Unfortunately, the planets in our solar system seem to have really random orbital frequencies, and when we try to put them together, they form complex ratios which, as I mentioned earlier, translate to dissonant and clashing sounds. Well, so much for centuries of belief that our universe has some sort of divine harmony. It's quite a bummer, right? But remember, our Sun is only one of the billions of stars in our galaxy. And to find another star system with more harmonious resonance, we actually don't have to look that far. Just 40 light years away lies TRAPPIST-1, a star with 7 planets within its system. And because the system is much smaller than the solar system, and the planets are much more compact, they developed a phenomenon known as orbital resonance, in which the gravitational influence of orbiting bodies put them into stable orbital patterns, usually involving simple ratios. When we map out the 7 planets of TRAPPIST-1 and their respective orbital frequencies, we can approximate a regular and simple ratio between the planets. And since simple ratios translate to consonant intervals, we should expect to hear something much more consonant and harmonious if I transpose these frequencies into our hearing range. So here's how it sounds. And if I notate the pitches, they actually form a pretty consonant chord. And just for reference, let's hear our solar system again. Okay, so if you really want the consonant intervals that Pythagoras envisioned, we gotta look to at least 40 light years away. Our solar system, unfortunately, doesn't fulfill any of the divine harmonics imagined by Pythagoras. Anyway, all of these are just really abstract, and we can't realistically hear any of the sounds different planets create. But hey, maybe there is some kind of higher being in another dimension that is capable of hearing these sounds, and each planetary system is just a musical instrument to them. Well, in that case, we're just really out of tune. And if we want to live in a much more in tune and consonant planetary system, we can consider moving to TRAPPIST-1 in the far, far future.